Welcome to this tutorial on build structures. In this tutorial, we will learn to create structures of small molecules, peptides and DNA fragments, modify structure, minimize energy and join models. To follow this tutorial, you should be familiar with Chimera interface. If not, for relevant tutorials, please visit our website. To record this tutorial, I am using Ubuntu operating system version 14.04, Chimera version 1.10.2, Mozilla Firefox browser 42.0 and a working internet connection. Here, I have opened a Chimera graphics window. Let us now start building a chemical structure using Build Structure tool. Click on Tools menu. Scroll down to Structure Editing option. From the sub-menu, click on Build Structure. A Build Structure dialog box opens on the screen. Click on the Start Structure button available at the top of the dialog box. Here, we have options to build the structure from the scratch. We can also modify existing structure, adjust bonds, adjust torsions, join models, etc. Let's choose Start Structure option. Here, there are many options to start a structure. We can add atom, fragment, fetch a structure from PubChem database, create peptide, DNA, RNA, etc. To build small molecules, click on Atom radio button. Atom parameter section opens. By default, the structure begins with a helium atom. Click on Center of the View radio button to place the helium atom at the center of the panel. We also have options to input the X, Y and Z coordinates. Click on Select Placed Atom. In the named text box, type the name of the session as sample1. Click on Color New Atoms by Element. Click on Apply button. A single helium atom appears on the panel. Now, we can modify this atom to any other molecule using Modify Structure option. Select Modify Structure option from the main drop-down menu. Let us try to modify helium to a methane molecule. Let the helium atom be in the selection mode. In the Build Structure dialog box, change the element to carbon, bonds to 4, and geometry to tetrahedral. Hydrogen atoms are attached as needed to satisfy the valency. By default, some of the parameters are already selected. Leave them as such. Click on Apply button. Observe the panel. Helium atom is now replaced by methane molecule. Using Select menu, clear the selection. To further modify this molecule to methylamine, select any hydrogen atom. Hold the Control key and click on any hydrogen atom on the methane structure. Hydrogen atom is now selected. In the Modify Structure dialog box, change the element to nitrogen, bonds to 3, geometry trigonal. Click on Apply button. Observe the panel. Amino group is now added to methane molecule. Clear the selection using Select menu. If you want to delete any atom or bond from the structure, select the atom or the bond. Click on Delete button in the Build Structure dialog box. To revert back to the original structure, add hydrogens using Tools menu. Using the center mouse button, drag and place this model at the corner of the panel. In the Build Structure dialog box, click on the drop-down menu and select Start Structure option. Now, click on Fragment radio button. A fragment library of various cyclic compounds is listed here. Click on 5-membered rings. Choose fragment from the list. I will choose imidazole. Click on Apply button. Imidazole molecule is displayed on the screen. To move imidazole molecule closer to methylamine model, uncheck the box for model number 0 on the active model status bar. This will make the amine model inactive on screen. Using center mouse button, move the imidazole closer to the amine model. We can join the two models on the panel using Join Models option in the Build Structure dialog box. Select one hydrogen atom from each model where you intend to form a bond. Hold Ctrl and Shift key at the same time. Click on the hydrogen. Now the hydrogens are selected. Click on Other Bond option. Information regarding the bonds is displayed on the dialog box. Click on Apply button. Observe the panel. Two models are joined. Close the session using File menu. Click on the lightning bolt icon present at the bottom of the window to get back to Graphics window. Next, let us create a peptide chain. In the Build Structure dialog box, select Start Structure. Click on Peptide radio button. In the peptide sequence text box, type the single letter code for amino acids. Let us type some random amino acid sequence. Type A, C, D, E, F, G, H. The residues are added from N to C terminus. Type the session name as sample2. Click on Apply button. Add Peptide Sequence dialog box opens. This dialog box is for specifying phi and psi angles. By default, phi and psi angles of -57 and 47 are displayed. These values correspond to the alpha helix structure of the peptide fragment. If you want to set the values, you can do so manually. For now, we will leave the phi and psi values unchanged. Click on OK button. Observe the panel. We have a peptide chain displayed as helix. To minimize energy of this structure, type minimize on the command text box. Press enter. A doc prep dialog box appears with model name. By default, some parameters are selected. For now, we will not make any changes. Click on OK button. This opens another dialog box to add hydrogens to the structure. A few parameters are already selected. Click on OK button. Observe the panel. Hydrogens are now added to the structure. Another dialog box opens. Choose the force field package. By default, amber FF14SP is selected for standard residues. Click on OK button. It will take a few seconds to minimize the structure. Now on the panel, we have a structure with most preferred conformation. Close the session using File menu and open Graphics window. Using Build Structure tool, we can create a double helical DNA or RNA. Click on the radio button, Helical DNA RNA. In the sequence text box, type one lettered nucleotide code for a DNA fragment. For demonstration, I will type ATGC, ATGC. Click on DNA. Click on B form. Edit the name as sample3. Click on Apply button. A model of DNA as double helix is displayed on the panel. Change to atoms display using presets menu. Let's summarize. In this tutorial, we have learnt to create structures of small molecules, peptides and DNA fragments, modify structure, minimize energy and join models. For the assignment, join two benzene molecules to build a biphenyl molecule. Build a peptide fragment with your own choice of amino acid sequence. Build a RNA fragment with a random nucleotide sequence. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials and give certificates. Please contact us. The Spoken Tutorial project is funded by NMEICT MHRD Government of India. This is Snehalata from IIT Bombay signing off. Thank you for joining.